Have you ever wondered how we see the world in 3 dimensions? It's all thanks to depth perception. Depth perception is our amazing ability to judge how far or near objects are. It's what helps us navigate our surroundings, catch a ball, and even appreciate art. Without depth perception, the world would look flat like a photograph. Imagine trying to walk down a staircase without knowing how high each step is. That's how important depth perception is for our daily lives. Now, let's explore the fascinating ways our eyes and brain work together to create this 3D view of our world. Get ready for some eye-opening science. You might be surprised to learn that we can perceive depth even with just one eye open. This is thanks to monocular cues, which are visual signals that each eye can perceive independently. These cues help us judge distance based on the relative size, position, and detail of objects. One such cue is relative size. Think about looking at 2 trees. The larger tree appears closer because it takes up more space in our visual field. Texture gradient is another helpful cue. Imagine a field of sunflowers. The closer sunflowers appear more detailed and spaced out, while those farther away seem denser and smoother. Interposition occurs when one object blocks our view of another. This overlap tells us that the blocked object is farther away. Lastly, linear perspective uses converging lines to create an illusion of depth. Think of railroad tracks. They seem to meet in the distance even though we know they run parallel. Pretty neat, right? Now let's talk about binocular cues, which require both of our eyes to work together. These cues provide even more precise depth information, especially for objects that are relatively close to us. Our brain is a master at combining the slightly different images from each eye to create a single 3D image. One of the key binocular cues is retinal disparity. Because our eyes are separated by a short distance, each eye receives a slightly different image of the world. The brain compares these 2 images, and the difference between them, called retinal disparity, tells us how far an object is. Another binocular cue is convergence. When we focus on a nearby object, our eyes turn slightly inward. The brain detects the angle of convergence, which provides further information about the object's distance. These binocular cues work together seamlessly, allowing us to accurately judge depth and interact with our surroundings with incredible precision. So there you have it. Our brains use a combination of monocular and binocular cues to create our rich 3D perception of the world. Monocular cues like relative size and linear perspective give us clues about depth even with one eye closed. Binocular cues like retinal disparity and convergence provide even more precise depth information by comparing the slightly different images from both eyes. Together, these cues make it possible for us to navigate our world, judge distances, and appreciate the beauty of our 3-dimensional surroundings. It's a truly remarkable feat of visual processing, and it highlights the incredible power of our brains and the importance of our 2 amazing eyes.